Very good morning to all. Today we will discuss about rotational motion. Now, up to our last classes, we have focused on mainly on translation motion, and that is the translation motion in which the object moves in a straight line or curved line. And now we turn into the motion into the rotational motion, in which object turns or the rotate about a axis, that is rotation in a circular fashion. That is the rotational motion. And in your daily life we can see that is if you walk in a straight line or curved path to get from one place to another, and the rainfall all depends on critical geometry in architecture infrastructure. And that is at a glance the life may be in a linear motion or in angular motion. Angular motion is also known as rotational motion, and the linear motion also known as translation motion. Angular motion, rotational motion. Okay. And this rotational motion, that is the motion in a circular fashion. It may be uniform or non-uniform, but it has to be circular. Yes, this is the important. The motion may be uniform or non-uniform, but it has to be circular. This is the important point. Or we can define this rotational motion, that is the rotational motion refers to anything spinning or moving in a circular path. It is angular motion or circular motion or the rotational motion. And the revolution of the earth and other planets around the sun may be considered as the rotational motion, but actually it is not a rotational motion. Why? Because if we consider the rotation is in the circular fashion, it is a rotational motion, but actually it is elliptical fashion, that is a slightly oval shape. Actually it is not an example, but if we consider it is a circular fashion, we maybe take for the example of for the rotational motion. And another example is the spinning top, that is the pambaram. How to rotate the spinning top എല്ലാവർക്കും അറിയാം. പമ്പരം റൊട്ടേറ്റ് ചെയ്യുമ്പോൾ പമ്പരം സ്വന്തമായി അതിൻ്റെ ആക്സിസിൽ കൂടി റൊട്ടേറ്റ് ചെയ്യുന്നതിൻ്റെ ഒപ്പം തന്നെ ഏതോ ഒരു അൺനോൺ ആയിട്ടുള്ളൊരു ആക്സിസിന് ചുറ്റും കൂടി റൊട്ടേറ്റ് ചെയ്യുന്നുണ്ട്. ദാറ്റ് ഈസ് എ വെരി ഗുഡ് എക്സാമ്പിൾ ഓഫ് ദി rotational motion. And also the earth revolves about its own axis, that is another example. And the rotation of the wheel and the rotation of the wheel of the helicopter, these are the good examples of rotational motion. Okay, this is the rolling balls. These are the examples. And also we remember about the Newton's laws of motion. Newton's first law, that is the law of inertia. Newton's second law, that is the concept of the force. And Newton's third law, that is the opposite, equal and opposite reactions, that tell about equal and opposite reaction. And now we go to the section that is rotational motion versus translation motion. In physics, any quantity that can be described in linear terms can also be described in angular terms. The most important of these are displacement, velocity, acceleration, force, mass. Okay. In the displacement, in the rotational motion, we replace this displacement by the angular displacement, because this rotational motion involves particle at a particular distance r from the axis of rotation. So it is angular displacement. And the velocity also replaced by the angular velocity. This the terms that is omega. Omega is denoted by angular velocity, not that point. And this Vt, that is equal to omega r. Vt is the tangential velocity. Tangential velocity is simply omega into r. And acceleration, and this in the angular acceleration, this is denoted by alpha. So there is the concept of the centripetal acceleration. Okay, now the force, concept of the force. Here the force is in rotational motion, the force is replaced by torque, that is a new variable. And the definition of torque is equal to F cross R, that is the product of R and the distance of its action from the axis of rotation. Here this cross signifies a vector cross product. Vector means it has the direction. Okay, and this mass, here the mass is in rotational motion, the mass is replaced by the moment of inertia concept, but the moment of inertia concept, it also depends on the distance, square of the distance, and also directly proportional to the mass. If mass increases, moment of inertia increases, and if the distance increases, the moment of inertia also increases. And now we consider radians and degrees. And in rotational motion involves the studying the circular path, so there is the presence of the degrees and radians. Okay, just note these points. And this next is the axis of rotation. That is for the rotation of an object, there is a fixed reference axis is necessary, that is the axis of rotation. And the next important concept is the moment of inertia. Moment of inertia means it is the measure of how hard is it to change object's angular velocity, that is it is the resistance of the object to change its angular velocity, that is the moment of inertia. And it is this, not this point, this moment of inertia, that is denoted by I, proportional to mass and square of the radius. And next is the conservation of the angular momentum, that is the law of conservation of angular momentum in rotational motion is analogous to law of conservation of linear momentum in the translation. Here L is equal to I cross omega, I omega. L is the linear momentum, omega is the angular velocity, I is the moment of inertia. And this is the important concept of the centripetal force. This is we have already learned about this.